Hello, everyone. I'm Dr. Ilana McDonald from the University of Toronto, and I'm going to mute my own audio because we're getting some feedback here. But yeah, hi from Segovia, Spain. Here to watch the total solar eclipse that's happening here. It's going to be a sunset total eclipse, so it's happening just under an hour before sunset. And I'm gonna be guiding you through the whole thing from this field out here in the middle of nowhere, um, just outside of Segovia. So as you can see, the eclipse has just started. You can see that there is a little bite taken out of it already. So we're well on our way to getting close to the exciting bits. You can see today also that there are several sunspots that we can see on the sun. There's a few off to the left side of the sun from our point of view right now, and it's looking really nice. Just got a new filter for my sea star, so you can see a whole lot of detail on the surface of the sun. So feel free to ask questions in the chat. My colleague Kara, who's helping me out in Toronto today, is going to highlight some of the ones for me to answer. So if you have any questions, feel free to ask and I'll answer them in stream. I thought to start off with, I'd show you a little bit of what is happening here on site. So join in just with my phone because sometimes that's the best way to do things. So here is the view from my phone. You can see this is the skyline we're looking at. You got the sun bright guy right up there. You can see there's actually a few people gathered in this field. You can see the beautiful cathedral in Segovia off in the background there. That's a hospital that we're next to right now. Lots of beautiful mountains. Uh, you know, it's a great spot, but very wide open space. A great view of the horizon, as you can see. And then this is my little setup right here, our little sea star friend that is providing us with the images of the sun right now. So my plan is at totality, I'm going to remove the solar filter. Hopefully we'll be able to see the corona. And so I'll probably be pretty quiet during that time. But in the meantime, we'll just watch the moon nibble away at the sun. Okay. So I thought I'd talk a little bit about eclipses. So of course, I see a few of you are watching from Toronto and Waterloo and various other places. Um, and so this is the view that was supposed to be in Toronto today. It's a partial eclipse in Toronto. Um, there is, of course, just a little nibble out of the sun, and the maximum would have happened just a few minutes ago, but of course it sounds like it's pretty cloudy in Toronto today. We were blessed with perfectly clear skies here in Segovia, but not so much luck there in Toronto. Yeah, so I mean, eclipses, maybe you know, maybe you don't know, but they basically happen when the moon goes in front of the sun, passes between the earth and the sun, and casts its shadow onto the earth. And so what you're seeing now is the moon just starting to cast its shadow onto the earth. And basically, there are two parts of this shadow. There's the umbra and the penumbra. The penumbra is where you see a partial. So currently, we would be in the penumbra of the moon's shadow, and the umbra is where totality is happening. So that's what we'll see for a whole minute at around 8:30 my time, and I guess about 2:30 Toronto time, 2:30 p.m. Uh, so, um, we don't, of course, get to see an eclipse every single new moon, which is when the moon passes between the Earth and the Sun. But we do get to see it occasionally only because the moon's tilt with respect to the Earth's orbit around the Earth is well, it's tilted by about 5 degrees. So that means there's only actually 2 points in the Earth's orbit around the sun where the moon can actually, um, pass directly in front of the sun from our point of view. Um, so Uh, yeah. So that means that, you only have this possibility twice a year, and then also, the moon has to be perfectly in a new moon phase in order for that to happen. So we generally get an eclipse somewhere on the Earth about every 2 years on average, a total solar eclipse, I should say. Um, but it's always in a vastly different spot on the Earth. So, this is our path of totality today. I've highlighted where I am right now in Segovia, um, with that black circle there. Um, so the path passed through um, Greenland, Iceland, a whole bunch of ocean, and now is passing through Spain. Um, and uh, the totality for us is going to last only about uh, a minute, but there is lots of partial eclipse to be had, and in fact, um, big portions of Canada, like a lot of eastern and also northern Canada, get to see a very deep partial. Up by Eclipse, for example, in Nunavut, it was a up to 66% obscuration, which is a very deep eclipse. And in other places, it was a little bit less, as I showed already in Toronto. It was it was just a little 8% bite taken out. It did include the information about when it was supposed to start and end, but of course, if it's cloudy, then unfortunately you won't be able to see that too much. Um, so this is actually my second total eclipse. The first one I saw was the one in April of 2024, which we also did a live stream for, when it passed over big parts of southern Ontario and Quebec, and also the Maritime provinces and Newfoundland. And that was, of course, extremely exciting. This is the view. This is actually a picture that my colleague Kara, who's moderating the comments, took of the eclipse. We were on the Grand River down in Chiefswood Park on the Six Nations territory, and it was just an incredible day. And of course, this is a picture taken by the director of the Dunlap Institute, Suresh Sivanandam, right around the edge of totality, where you can see the solar corona and the a little tiny diamond ring effect. And actually, we did see a lot of solar prominences, which you can see right on the bottom of that image as well. So it's a really beautiful view. And of course, when totality happens here, I plan to um, be very quiet and just enjoy the moment because it's going to be very exciting. I'll leave my camera on because I'll probably make some very funny comments at the time. But yeah, it's going to be a good time, and I'm excited to see this view once again. So, of course, if you are in a location that isn't cloudy and is in the region of the partial eclipse, you're in the region of totality where totality hasn't happened yet or has already happened. Um, be sure to wear those eclipse glasses. This is me, my eclipse glasses back in 2024. Um, and do protect your eyes from the sun, and you should be wearing them during all partial phases of the eclipse. In fact, if you just want to look at the sun on a random day, you should wear those glasses as well, because any sort of looking at the sun is very, very dangerous if you're not wearing the right protection. Um, Now, I should mention that you should probably make sure that they are not counterfeit. They have to have that ISO 12312-2 2015 certification on them. And if they don't have that, then be very suspicious of their provenance. But If they do have all that, then it should be good to look at the eclipse, and they shouldn't really go bad. So if you save them for the next eclipse or some other time when you want to just look at the sun, then go for it. All right. Um, I should also mention that during totality, this is a time when you actually don't need to wear solar glasses, but this is a time when the moon has completely covered up the sun, and so it's safe to view the sun without protection. But it's only during those few moments. So I'm going to take the solar filter off my telescope, and then be very careful to put it back on before totality ends. As soon as we start to see that diamond ring effect. Um, um, be on the lookout for that. So it will get very dark and then very light, and then very light and then very dark again around totality. All right. So it looks like our view is starting to get a little bit more deep. I have my own eclipse glasses that I brought. They're these fancy ones. You can see on the inside, upside down. On the inside, they have that ISO standard, so I know that they're safe to use. And they look really goofy on me, but when I look at the sun, I can see the same view as you see through the sea star right now, which is so freaking cool. This is my favorite moment. Is just as you see that little uh, shadow get deeper and deeper into the sun. Right. I'm gonna look at those comments right now. If anybody has any questions about eclipses, about what it's like here today, it was very, very hot. It's actually starting to get cooler now, which is lovely. Um, any questions at all, feel free to put them in the chat and Kara will highlight them for me and I'll be happy to answer them. So feel free to put some in chat. And I'm just going to enjoy the eclipse for a moment. So it looks like we do have one question in the chat from U of T Psychology. Hello, U of T Psychology from sunny Segovia. The question is, how much cooler does it get during totality? And I'm going to answer both meanings of cool in this case. It does get, like, temperature-wise, quite cooler when we experienced the total solar eclipse in 2024. I'd say it got about 10 degrees cooler. It was a noticeable difference. Like, I was wearing a t-shirt at the beginning of our live stream, right when the partial eclipse phases were starting. And then I um, had to be wearing a big sweater and fingerless gloves as soon as totality happened because it got so much colder. Um, so yeah, significantly cooler in terms of temperature. And then in terms of like, wow, that's so neat. In terms, sorry, in terms of actual um, like coolness factor, it just gets a million times cooler because you can see that corona. The sky gets really dark. Hopefully, we'll see it this time. Um, and, there's a lot going on. You start to see stars during the day, there's just so many things going on that are so interesting and so neat, so, yeah, it does get significant. Oh, you just saw a bird go across. It does get, significantly, cooler, during totality. I just realized that I should be taking a time lapse of this. I'm gonna do that right now and do that. Actually, maybe this is so we have records of our adventures here. Okay, let's do that. Or the little red button now. Um, yeah. So thanks for that question, U of T Psychology. Um, if anyone else has questions that they'd like me to answer on stream, I'd love to answer them. Uh, I see a comment from Eleanor Gang. Hi, mom. This is my mom. So, talk about birds' roosts is not really a question, but it is a statement, and people tell me to talk about things. Um, so I shall. But yes, when totality happens, the birds think that it's nighttime, and so they stop singing their songs. They get very quiet. They start to go to bed, and they think that uh, it's time to do that, and then they get very confused when totality ends and it's morning all of a sudden. So thanks for that statement slash question, Eleanor Gang. So I think that the sun might be at a point where, and I'm gonna see if I can do this. Actually do like a little pinhole camera and shadows start to get weird. So I'm gonna try this. We'll see if it works. I'm gonna get my little camera situation back in here. So here you can see my camera view again. We can see this field, like it's actually got a lot of people in it now, um, going around. But yes, oh, my foot's fallen asleep. One of the interesting things you can do during an eclipse is with shadows, and I'm going to try and do this with my fingers, is you should be able to cast a shadow. Oh man, can I actually do this? Onto a thing. And okay, maybe this is a bad idea. I'd have to put my hand way over. Okay, so you can sort of see it. I had it for a second there. You can sort of see that it makes a crescent instead of a dot in the shadow. I don't know if it's actually showing up properly. Anyway, a cool thing you can do is to have a pinhole camera, and the image that's projected actually looks like a um, a little eclipse. Yes, Mutant Log just said, here, is using a colander during a partial eclipse as a pinhole camera is actually quite fun. Um, I highly recommend it. Um, and what you would see is tons of little tiny images uh, of the eclipsing sun uh, on the ground or whatever it is you're projecting on. And so I'm going to leave you with another little image of the sun and see if I can find some sort of pinhole camera. Okay, I think I figured something out. The strap on my hat has little tiny holes in it. And if you look at the shadow close up, it is just circles. But as you get farther away, you can see that it makes a whole bunch of little eclipses. That's fun. Hope everyone can see that. So, pinhole camera effect demonstrated. I also had brought with me these. Here, I'll just get rid of the camera view. Um, Eclipse binoculars. They basically um, show the same view as the sea star, roughly, but a little more zoomed out, and same view seeing there, um, but live to my eyeballs. We had Mutant Log in the chat ask, "Can we bring the camera in closer to the shadows?" Yes, we do that just for you. So let's do that again. A little demonstration. So we've got our circles there. Hope that's close enough. Sorry, it's hard for me to do this like that. There. So nice and close. And then we bring this farther away. Oi. Okay, maybe I bring it further away and then bring it closer. Bring the camera closer. So we've got this going on. So we've got now our little crescents there. It's a little hard to see. I apologize. It's not the optimal setup. I did not plan for this part, but there you see them. Little eclipses. There we go. Anyway, hope that was fun for you guys. So we're getting up to almost 50%. We've got the partial eclipse in Sherbrooke. Eleanor Gang, do you want to comment as to how deep of an eclipse you actually saw? I think in Sherbrooke, Quebec, it was a little bit deeper of an eclipse than it would have been in Toronto. Not quite half, but I think around 20% maybe. Um, so good. All right. While we're waiting for more questions to appear, oh yes, about 1/5 of the sun was covered in Sherbrooke, Quebec, in that partial eclipse, and that would be about 20%, as I said. Yeah, excellent. Thank you, Eleanor. Okay, I'm gonna stop chit chatting for a little bit and let you all enjoy the view of the eclipse, and I will also continue to enjoy the view of the eclipse. So apologies, folks, right now. It seems like we're having some technical difficulties, but I will try to get our Wi-Fi back online in just a moment. So please be patient. Don't worry, totality hasn't happened yet. All right. So we did have another question from, oh boy, Arun Kashi George. So where are you right now? Because here in North York, it's so cloudy and rainy. Well, I'm in Segovia, Spain, which explains why it's not cloudy and rainy here. Here we're in the path of totality, and we are currently at about, oh, I don't know, maybe half of coverage, maybe a little bit more at this point. I said lost my eclipse glasses and they're right on my head. But yeah, it seems like it's half covered up. I might try that pinhole thing again now that the sun is a different shape, but maybe I'll wait a little bit. But yes, in Segovia, Spain, in the path of totality, and yeah, it's nice. Oh, and then there was a little bit of discussion. You were asking where someone else was in the stream, but yes. All right. Yeah, and getting closer and closer, getting quite a bit cooler here now. Like a lot cooler than it was during the day, which is interesting. And oh my, people in the field all the way down here. Hello. And I'm going to show the camera view again because there are this is the question of where did I put my phone? Right, it's here. I don't know if you can see in the distance there, but there's actually some like hot air balloons that are starting to go up. And I think that they plan to be in the sky when totality is happening, which is kind of the coolest thing ever. That's neat. And I guess I should show again in the field. So we have a couple of people in front of me here. I don't think that they're going to block the view of totality. And then we've got good old sea star, handy sea star up there. A few more people in the fields. Um, Somebody else has got a camera over there. We've got folks hanging out watching. A lot of people wearing their eclipse glasses. Beautiful Segovia, Spain, off in the distance there. You can just see the peak of the cathedral right there. I don't know if you actually can. It's hard to see. And then yeah, people have parked along the road here to watch, and there's mountains behind me, and more people off in the fields over here. And it's a very big field, but it actually does have a lot of people in it right now, which is neat. And I don't know if you can tell from just like the camera view, but it's like actually a little bit darker. Oh, you can see one of those hot air balloons taking off. Man, imagine that, being in a hot air balloon for totality. That would be the coolest thing ever. Maybe I'll find some of those people after and see what they thought the experience was like. All right, I'm gonna be quiet again and let you all enjoy the beautiful view of the eclipse. I'd say we're about 60 to 70% covered now. So all right, we have a question from Filthy Jasmine Tea here. Is there anything special that happens when your view of the eclipse is so close to sunset? That's an excellent question, and I think it does actually change the view because the shadow that the sun is casting on the Earth, or because it's so low on the horizon, and it's such an angle, is going to be very extended. So I'm curious to see like atmospheric effects are going to be happening at that time. Um, I'll probably comment on them. I don't know if I'll show them necessarily. Yes, I do believe that it will be a little bit different than what it looks like when there is totality that's higher up in the sky. Good question. Thanks. Actually, I saw that there are friends watching from the University of Toronto Astronomy Lounge, so I just wanted to say hi to them too. Hi from Segovia, Spain. Thanks for tuning in. Hope you're as excited to see totality, though I might be a little bit more excited. All right, let's keep watching that eclipse. Okay, so something you'll actually notice here is that in the beginning, the image from the sea star was a very bright white color, whereas now it's quite yellow. So the filter that I have is actually a yellow filter, or sorry, a white light filter, not a yellow filter. A lot of Eclipse filters are white light filters. Sorry, I'm just going to hide that comment just for a sec, but I'll get back to it. Um, and it's actually picking up a whole lot more yellow than you'd see before. And I think that's because it's fairly low on the horizon. So that's interesting. Okay, and we did have a question from Yolanda Cunningham. Uh, Hello, why does the temperature drop during a solar eclipse? Well, that's an excellent question, Yolanda. And it is because simply the sun's light is being covered by the moon. And, you know, heat that we get from the sun is from the sun's light. So, of course, like, our atmosphere will retain some of that, but a lot of that light will, uh, be blocked out, and so it gets noticeably cooler. And actually, I'm noticing now that we're down to just a little crescent, is that it is actually getting quite a bit cooler here. I'm just going to try to adjust the brightness a little bit, so maybe um, we can go a little bit less exposure and see those sunspots that we can still see there. Yeah, but good question. It's yeah, because the sun's being blocked. So, when the sun goes behind a cloud or something, it gets noticeably cooler as well. When you're standing in the shade, it gets cooler. So this is just shade being caused by a huge drop. Thanks for the question, Yolanda. All right, I'll get that eclipse view back on, and I'm going to be doing little tiny adjustments as we go to get the best view possible of the eclipse for you all. All right, we have another question here from the Alexis Bud. The question is there a delay in the change of light versus the change of temperature? As in, does it get darker before it gets cooler, or are the changes simultaneous? From my experience, they're actually pretty close to simultaneous. Um, so I've noticed that, like, it's a very instant change in temperature, um, from, you know, uh when totality gets, to happening and, and when you actually notice it getting colder. And actually right now, we're just at a little tiny sliver of the sun. We're about 7 minutes from totality. Oh my gosh. Um, and it's, yeah, it's getting very cooler. It's getting like, I'm noticing the temperature differences quite a bit. Okay, thanks for that question, Alexis. Yes, they are more or less instantaneous. We have another question from Dave Torres. Do you think you'd be able to see the Bailey's beads effect there during this eclipse? That's a great question. So, Bailey's beads is a phenomenon where you just see like a little tiny bit of light, but like as little droplets almost, beads around where uh, like right before totality or right after. And that has to do with the fact that there are craters on the moon. So it's not a perfectly smooth surface, even though it looks fairly smooth in this image. Um, and yeah, and so the beads effect happens when you do have craters that are lined up with the sun's light. I don't know if we'll be able to see them this time, but I'm going to keep an eye out for it, and I'll let you know after it's while it's happening. We also have a question from Dylan D. Films. What time will totality be at? Great question, Dylan. Um, it should be happening at 8:31 Segovia time, which would be 2:31 Toronto time. Uh, I just noticed a whole bunch of birds are starting to go onto the telephone line, and I think they think that nighttime has come early. Um, that's crazy. And actually, if you sort of like side eye the sun right now, you can actually see just the little crescent. So I'm going to take a look see at it. Oh man, that's so cool. Yeah, that's awesome. And I'm also going to throw in this guy, which, like, you can see the sun now. I don't know if you can actually tell, but you can tell that it's a lot darker. And I don't know if you can see these phone lines over here. Oh, a little further. Oh, it's so hard to see it so small. But yeah, there's a whole bunch of birds that are sort of coming to roost. I think it's a bunch of pigeons and doves are coming to roost on this line over there. Oh, and those balloons are way up in the sky now. Um, that's so pretty. Okay, yeah. So again, it looks like it's sunset conditions, but the sun is not low enough to be set yet. So that's cool. And then, oh, one more question before totality. Oh, sorry, I just accidentally looked directly at the sun, which I told you not to do. Uh, so, what is the longest recorded totality? Are there any significant historical? Oh man, that would take so long to answer, Alexis. How about I'll answer the second part of that question after totality happens? But as far as I know, the longest totality was think I want to say like around 10 minutes. I know that the next one that's happening in 2027 is going to be 7 minutes, which is quite long for totality. But I think it's around 10 minutes. It's the longest it can possibly be. Good question, though. I'd have to look that up the exact number. But it's a few minutes. Oh, yeah. So close. Okay. I'm going to switch now. We're only 3 minutes from totality. So I'm going to switch to just the view of the eclipse. And um, yeah, and we're just gonna like live through that together. I'm just turning this on because the light's getting really dark and it looks awesome. Oh man, oh man. Holy fuck. Oh wow. Oh man. This is freaking incredible. I don't know if this mic is working at all, but it's really cool. It's just like so I know you can't see it on camera really, but it's so dark and it's so beautiful. And holy cow, that totality is incredible. I'm just gonna watch it now, but I'm gonna leave the camera on. Oh, that's it. That's what we get. Oh no. Wow. Wow, wow, wow. Oh wow. That how do microphones even work? That was something else. So already the sun is coming back and it was like a second sunrise and it's still just like a little sliver. And Mao, 1 minute of totality passes fast. So fast. I needed a moment there. But you can see now that the sky has gotten brighter. While the total eclipse was happening, I could see Venus in the sky. Um, I was too overwhelmed to see much of anything else. There are birds that are like waking up now. Actually, you can still kind of see Venus in the sky. That's pretty cool. Um, like they all went onto the clothesline, power lines, uh, and now they're like flying around, all confused. Like, oh, I guess it's morning again, but not actually. Oh man, that was incredible. Yep, now the whole thing in reverse. Now we get to see the sunspots on the other side of the sun slowly appear. Um, wow. Okay. I guess I could answer the rest of Alexis's question, which was Are there any significant historical eclipses? And I guess there have been many. One of the big things was um, proving general relativity with a solar eclipse. So during totality, as we just saw, you can see stars during the day. So if you photograph the sun, you can actually see stars next to the sun, right? And because the sun is a very massive object, it curves space time, and therefore the apparent positions of the stars would shift slightly during an eclipse versus not during an eclipse. So that is what you'd notice. Sorry, I'm just like still in a weird emotional state. You really gotta be there, I guess. But anyway, yes. So yeah, the theory of general relativity was essentially proven during an eclipse because the stars next to the sun were in a slightly different position due to the curvature of space-time. So, uh, yeah, that's that question. Um, DDO Defenders, thanks for asking. How is the feeling? It's so bizarre. You start to see the sun disappear. By the way, we did see Bailey's beads there. I don't know if you noticed in the view of the sun, but yes, Bailey's beads did appear, and see like little beads. Yeah, but yeah, so as the sun was disappearing behind the moon, you just get this like incredible corona appearing. It was just, it was like incredible excitement and euphoria, and it's just awesome and wild and amazing. I don't know what else to say. It's incredible. Um, yeah, great feeling. Thanks for asking. All right, I'm going to leave us with a little bit more of a view of the sun, and then I think I'll finish up the stream because I got to catch a train to Madrid before the last train runs. So here's that view. If there's any last minute questions, feel free to ask them in the last few minutes. And I'll end in maybe 5 minutes or so. Okay, one last question for the evening or afternoon for folks in North America. I know we just had one, but when is the next one you mentioned, Ilana? 2028? It's in fact in 2027, August 2nd, I believe. It will be visible across North Africa. You can actually also start to Spain, so that's cool. Yeah, it won't be visible from North America at all, unfortunately, but if you have a chance to travel, it's going to be a good one. And we'll have 7 minutes of totality, which is, I think in Egypt, the longest. I'm hoping to go see it somewhere along the path. So maybe I'll see you there, and we'll do another one of these. This has been fun. All right, one last view of the eclipse, and then thank you all for coming. And yeah, hope you enjoyed seeing the eclipse with me.